Hello guys, welcome back to John's Workshop, and in this video we're going to be going back onto the flame licker engine build and the Marc engine, and we're going to be making the flywheel, and I'm looking forward to this. So I've kind of saved the best bits till last on this engine, if you like, or the most interesting bits at least from a manufacturing perspective and setup. So looking forward to this. So as I've got on the board there, it's made of mild steel. Now that's what it calls out on the drawing. I did think about going brass or stainless, but just the pure cost of raw materials at the moment in the sizes that I needed was just prohibitive. So mild steel it is for this first engine. We'll think about what we do with that mild steel to protect it from corrosion once I've got it all made and built, and we'll have a look at what we can do with that. There's some turning work, obviously being a flywheel, you'd expect nothing else. There's a bit of milling work, putting some holes in after the turning's done, and as I've written at the bottom there, I'm taking advantage. And what I mean by that is I've just recently finished manufacturing the swivel bases for the vice collaboration, and a lot of the tooling that I've got set up in my holders on the lathe at the moment are absolutely ideal for this flywheel. So trepanning tool, I'm going to need to use the small boring bar, things like that. So we've got lots of tooling already set up, which means now's the right time to put the flywheel up. Got the forge jaw on the lathe already, so lots of reasons to crack on with the flywheel. So I'll join you just shortly at the command and control centre, and we'll just have a quick look at the flywheel and the plans, and then we'll go to the lathe and crack on with the manufacture. Right guys, we're just up at the screen very quickly just to show you the flywheel. It's a flywheel, they're all pretty similar. So this is, as I said, mild steel, simple flywheel design, rebated sides, both sides of the flywheel, and a pattern of holes drilled in it, and a central bore with a locking screw going through the centre. So you know, quite a simple part to make. So we'll join you on the lathe just shortly as we're getting the billet that I've got for this, which is here, into the lathe, into the forge jaw, and set up to start turning the flywheel up. Right guys, we've got our billet in the forge jaw chuck. I've trued that up within a couple of thou. For what I'm doing here, that's perfectly good enough. So we're going to face off, turn the OD, drill, ream in the centre for the shaft, and then get the trepanning tool in and trepan the middle piece out, the recess out in this side. I've just about got enough to turn the full width of the OD on this side, so that'll be fine. We can then turn around, hold on that OD, clock everything up, get parallel to this back face to face the back face off, and trepan in the other side the same. So that's what we're going to do now. my little trepanning tool's earning its money. It's performing reasonably well. So we've got that roughed out. I've finished my small diameter, that's done. I just need to finish my ID now and then take a skim across the back face, but largely it's cutting, it's cutting very well, cutting very nicely. So we'll just finish that off now. Should be 66. 6601 that way. We should be 20 this way. We're 2001. And I know we're 6mm deep. So I'll just break this edge. This corner, I've done the centre corner, I'm just going to break this outer corner. Don't need to watch that, it's only a chamfer. And then I'll bring you back when we've turned this round, and we're going to be doing basically facing it off to finish thickness and then doing this same operation on the other side. But I'm pleased with that. That's left a reasonable finish. I might just do a bit of polish up while it's on the lathe in there, and then we'll call that done for this side. Right guys, we've turned the part round. I've switched my jaws around the other way, and I'm just holding this direct in the jaws. Shouldn't mark it because I will hopefully not mark it, and if it does I'll just give that a clean up afterwards. It's not going to dig in, it will just be a surface mark. So what I've done is put the, because this is a 6mm reamed hole in the centre, I've put a 6mm dowel, or 6mm bit of drill rod actually through the centre there, and I've just set my DTI up, and what I've done is wound my cross slide till I'm on centre, and I'll need to move that again because obviously the part's off centre at the minute, so I don't really know where centre is at the minute. So we'll get it somewhere near, so we can see that's a high jaw. See, that's a high jaw. I'm somewhere near there now, so I'm just going to recheck my centre, which is there. So we're within 5 thou. So we're bang on there, no movement on the clock at all. So happy with that, we'll get set up to face this back edge off, chamfer it, and then back in with the trepanning tool to do this side. Right, we're on the second side trepanning now, and I didn't get really good shots on the first side, so I've tried to move the camera. It's right in my way, but we'll give it a go and just show you some of this trepanning, taking this centre out, this hub out the flywheel. Right guys, we're about to go to the mill and put this pattern of holes into the flywheel through the web, and there's 2 or 3 main ways I could do this, and I think on my last video when I did a PCD of holes I demonstrated the PCD function on the DRO, and I could quite easily do that again, but I thought just for a change and maybe to help somebody out who might not have seen this and doesn't have a DRO. So this is the way I learnt to do it on a manual machine back in my apprenticeship, excuse me. So we're going to use the good old Zeus book. Where's that? There you go. So we're just using the Zeus book, and on one of the pages in the Zeus book, as you can see there is a whole manner of hole PCD patterns that you can choose from. So this is a 6-hole pattern. So as you can see, Now there's really only one dimension that I needed to calculate on this, to be honest. The rest I knew just from the information that I'd got, which is they're on a 44mm PCD. So obviously this hole and this hole are on centerline in X, and they're 22mm out, so radial position. And then this way, obviously between that one and that one is going to be 22mm between those two. So I know what the Y position is going to be for both of those holes. So the only real position I needed to calculate was the X position, but I've calculated the Y as well for these two just from the Zeus, just to show how to use it. So if I bring the Zeus book up to the camera, if we look for our, let's just try and get it in focus, we look for our 6-hole pattern, which is here, and it basically gives us an A dimension, a B dimension and a C dimension, and they're shown on here. So there's the A. The B's, it's hard to kind of make out, it's not the best printing in the world, but the B is the distance from this hole to this hole in the y-axis, if you want to call it that, and the C is the pitch between this hole and this hole. So what you do is basically, to find these dimensions, you multiply your PCD value by the number that they give you in here. So they've done the hard work for you. So basically multiply your PCD number by these numbers. So that's what I've done, and you can see there, these are my answers. So I've got 19.052 in my X to this hole, so that will be positive this way, negative that way. So that gets me these 4 X positions. I know these two, so the only one I needed was the Y, which will be negative 11, positive 11 for these two. Nice and simple. So I'm going to use my DRO, but I'm only going to use it to wind to these values that I've calculated from the Zeus. I'm not going to use my PCD function. So hope that was helpful. This is a really useful thing, and you can see there, you know, these go right up to 12-hole PCDs. There's a bit of explanation at the bottom, there's a bit of explanation at the top. Dead simple to use and foolproof, hopefully. So we'll move to the mill now. I'll take my little drawing with me and we'll crack on and start putting the holes in. So guys, we're at the mill, so you can see my setup. I didn't want to take the vise off again, so nice easy setup. I'd still got the 1, 2, 3 blocks up on the mill from the last setup I'd done to the right hand side of the vise. So cleaned everything down, set the 2, 1, 2, 3 blocks up, sat the flywheel on it, clamp either side, more than strong enough. I've just put a bit of aluminium packer underneath so that I don't mark the surface of the flywheel with the clamp. Got my verdict clock device, dovetail clock device, centre finder in the chuck, and basically I've swept the central spigot diameter here because I know that's concentric to all the other features on this part, because it was all clocked in on the lathe. So clock that in 0, 0 all the way around. So I'm going to zero my DRO at that point, and then all I need to do is work to those numbers as I said on my drawing. So I'll bring you back in a moment when we've got the mill powered up and we're popping the PCD holes in. There we go guys, that's got the holes done. So all I need to do now is flip this over, deburr the other side of the holes the same, and then we'll give it a final clean up and wrap this episode up, and that'll be another bit of the Marc engine completed. Well, there we go guys, that's the end of the flywheel build. So that's all complete, other than a tiny bit of tidying up and polishing at final assembly just to remove any final bits of scratches and things like that that are on it. There's a few tiny marks, but so that's another bit of the Marc engine done, so I'm really pleased with that. So we're back onto the build. That said, I think next week I've got another job that's coming to the shop that's going to get in the way of the engine build again, so we'll get that out of the way first. But yeah, pleased with that. Nice and simple, nice easy job, and one of the sort of big draws of an engine really, because it's the bit that you see moving the most, I guess. So I'm hoping that this is going to run really true based on the way I've machined it, but again, first engine I've built, so don't know. So what I have done is left a tiny bit of material thickness wise and a tiny bit on the OD, so that should it run, once I've fitted it to the shaft, should it run a bit wonky, wobbly, I've got enough stock left on there that I can just clean everything up so everything runs true to the shaft rotation. So that's the plan, but we'll see. It should run fairly true how I've done it. But anyway, so hope you enjoyed that. That's, as I say, another bit of the engine done, and thank you to the subscribers for your continued support, and thank you to the new subscribers that are coming along, and we will catch you all very soon on another video where we'll be making something else.